Welcome back. In this tutorial, we will measure the power factor of a three-phase, full-wave bridge rectifier in Simulink MATLAB. Problem statement. Simulate a three-phase, full-wave bridge diode rectifier circuit and make the following measurements. 1. Power factor. 2. Efficiency of the rectifier. 3. Conduction loss of each diode. Getting started. So, let's get started. Launch Simulink. And open the previous model. Add the required blocks. Open the Simulink library browser, and then launch the standalone library browser. From the Sensors and Measurements section of Simscape, add two current measurement blocks. A mean block, two voltage measurement blocks, and two RMS blocks. From Utilities, add two ground blocks to the model. From the Math Operations section, add a divide block and two product blocks. From commonly used blocks, add two gain blocks. From sinks, add a few display blocks. Let's arrange the blocks. Connect one current measurement block in one of the three phases. Connect the other current measurement block in any of the remaining two phases. Connect a voltage measurement block to measure the phase voltage. Multiply the phase current and voltage using a product block to get instantaneous power. Then connect a mean block. Open the mean block and set the frequency to 50 Hz. Connect a gain block and set its value to 3. This will give us the total average power of the three-phase AC source. The mean block gives the average power of a single phase, and at the output of the gain block, we obtain the total average power of the source. Rename the display block. Connect the other voltage measurement block. Connect an RMS block to each of the current and voltage measurement blocks. Open each RMS block and set the frequency to 50 Hz. Connect each RMS output to the inputs of a product block. This gives the apparent power. Connect a gain block and set its value to 3. This gives the total apparent power of the source. Connect the display block and rename it. To find the power factor, divide the average power by the apparent power. Go to the Simulation tab and click Run to start the simulation. Here's the power factor of the circuit. This is the apparent power, and this is the average power of the source. The average power at the input is 26.45 kilowatts. The average power at the output is 26.37 kilowatts. The difference between these two powers is dissipated in the diodes. Now let's calculate the efficiency of conversion. Copy and paste the divide block and flip the inputs. Divide the output average power by the input average power. And then multiply by 100. Connect a display block. Go to the Simulation tab and start the simulation. The efficiency is 99.7%. Now, let's calculate the conduction loss of a single diode. The approximate conduction loss of a single diode is equal to the difference between the input and output average powers, divided by 6, as the total number of diodes is 6. The calculated conduction loss of each diode is approximately 13.33 watts. Next, we will measure the conduction loss across one diode. Open a diode block and enable the measurement port. Add a demux block from the library. Also add a product block from the math operations section. Add a mean block to the model. Connect the input of the demux to the measurement port of the diode block. This provides the current and voltage of the diode separately. Multiply them both to obtain the instantaneous power. Then connect the mean block to get the average power dissipated in the diode. Open the mean block and set the frequency to 50 Hz. Run the simulation. The conduction loss is equal to 12.85 watts. The power measured at the diode measurement port is lower than the calculated value. This discrepancy arises because part of the power is dissipated in the snubber circuit, which is not included in the diode measurement. Summary. In this tutorial, we performed additional measurements on a three-phase, full-wave rectifier circuit. Your task: perform the same measurements using a three-phase half-wave rectifier. Thank you for being with us.